chance to learn and grow with friends by our side. There's so much to know, from the ABCs to the stars up high. We're learning together, you and I. Learning together.
Okay, I welcome you all. For those that have been here from the start, thank you for actually coming on time. I believe others are still on the way and they will be joining us. So for that case, as we wait for others, we shall go through what basically we need to talk about today. So we are looking at differentiation 2, where we shall be talking about differentiation of trigonometric functions, exponential functions, logarithmic functions, and we shall talk about further applications. So basically, we shall be looking at majorly this one here, differentiation of trig functions, exponential and logarithmic functions, inverse trig functions. We shall talk about macrolinear theorem and further curve sketching. So this is all that is covered under differentiation 2. So I expect you to be having knowledge about differentiation 1. So you should basically be comfortable with the gradient of a curve, gradient functions, should be comfortable with composite functions, that is using chain rule. You should be comfortable with implicit differentiation. You should be comfortable with product and quotient rules. You should be comfortable with the applications, that is nature of turning points, curve sketching, small changes, rates of change, then velocity and acceleration. So this should be very clear, and I hope you studied this. This was supposed to be covered actually in the Sin 5 at term 2. So I believe you covered that. So we shall basically be talking about differentiation of trig functions from first principles. So if you want to look at differentiation, of trig functions from first principles, then what exactly is supposed to be done is what we shall be looking at in this session. So in this session, basically we shall be talking about differentiation of trigonometric functions, and we shall look at that by looking at differentiation from first principles. And to look at differentiation from first principles, we need to use the following identities. These are some of the identities we need to use when we are differentiating trigonometric functions from first principles. So let me hope that you covered what we call a factor formula from trigonometry. So is it true that you covered that? In case you did, then you will need to revisit if you don't recall some of these expressions here. So these identities will be very important when we are looking at differentiation of trig functions. And for that case, please make sure that you know how to use them, because we shall be basically looking at the application of these 4. We might as well need to look at also the compound angles. For example, if you have a sine of A plus B, can anyone unmute and tell us what this one is equal to? What is sine of A plus B equaling to? We need to look at these expressions from compound angles. If anyone knows what this one is equaling to, please, you can unmute and let us know. Sine of A plus B, how do we expand this?
It is sine A cos B.
Sine A.
Cos B.
Yes, please.
Plus sine B cos A.
Plus sine B cos of A. Okay, thank you. So that is basically how we expand sine of A plus B. And for that case, you must as well be able now to expand a sine of A minus B. So for this, what changes is only the sign. So basically, we have sine of A cos of B minus a sine of B cos of A. Okay, thank you for that. Let us look at the next. Anyone who can tell us how we expand this? Cos of A plus B. Cos of A plus B. You can unmute and tell us how we expand that. We shall be using some of these expressions here.
We say cos A, cos B minus sin A, sin B.
Okay, thank you so much. Cos of A, cos B, sin A, then sin of B. So likewise, we can therefore also talk about a cos of A minus B. Since this is a minus, what will only change would be the sign, meaning that this we expect it to be cos of A, then cos of B, then plus. If it is a minus in the expansion, we expect a plus. So sine of A, then sine of B. Some of these expressions will be very important. So you need to be knowing them, how we deal with cos plus cos, cos minus cos, sine plus sine, sine minus sine. They will be important when we are looking at a differentiation of trig functions from first principles. So for that case, let us again go on and talk about differentiation from first principles. And we want to begin with by differentiating cos of x from first principles. So you should now be ready with where to write if possible. So we need to look at differentiation of cos of x from first principles. So how do we differentiate cos of x from first principles? Okay. So basically, for those that have just joined, we are looking at differentiation of trig functions from first principles. And we said that to differentiate trig functions from first principles, you must be knowing some of these identities, especially factor formula and how to deal with compound angles, that is the expansions for sine and cos. So we want to begin with our first trig function, which is cos. We want to look at how best we can differentiate cos of x from first principles. So how do we do that? That is what basically we shall talk about. So we need to look at differentiation of cos of x from first principles. Okay. So we are looking at differentiation So let us talk about how best we can differentiate cos of x from first principles. So what we do here is, as you did in the differentiation of functions, that is, for example, if you are to differentiate x squared, I hope you looked at differentiation of polynomial functions. And the first step to do here is you create an increment in x, which will create an increment in y. Then you start simplifying from that given point. So we shall be following almost similar procedures. So when we are to differentiate cos of x, what we shall do is to simply let, we first let, for example, y to represent cos of x. If y represents cos of x, then bring in an increment in x. So an increment in x brings about an increment in y. And for that case, if you have an increment in x, that is a delta x. If you introduce an increment in x, it will bring an increment in y. And for that case, we shall be saying that y plus a delta y will be same as a cos of x plus delta x. You introduce an increment in x, which increment in x will bring about an increment in y. Here we have got different ways of how we can write the increments. Some can use that, or else you can use this. So basically, an increment in x brings about an increment in y. And what we do here is you simply take this one the other side. So this means that delta y will be same as a cos of x plus delta x, then minus y. When you take y the other side, it becomes minus y. But y is cos of x, so you will have minus cos of x. So that is what we shall have. So from this given point, what we can do is, you realize this is cos followed by cos. From what we talked about, cos followed by cos, that is what we call the factor formula. So if you have cos minus cos, you expect to have minus 2 sine of this angle plus this one divided by 2, sine of this angle minus this divided by 2. So that is what we shall employ there. So from here we shall have this as delta y. We shall have this as delta y, which is equal to, this is cos minus cos, so we expect to have minus 2 sine of, get this angle, add there this angle, that is x plus delta x, add there x. Then divide this by 2. Divide this by 2. And then again, you have a sine of, again you have sine of x plus delta x. Then you subtract, you get this angle, add there this. Then next you get this angle, subtract this. So subtract x, divide this by 2. So from here we shall have delta y, which is equal to minus 2, a sine of, try to simplify this. This is 2x plus delta x divided by 2. Then sine, you can now have x minus x, it will cancel out. You remain with delta x divided by 2. So I hope everyone is okay with these steps that we have so far done. So from this given point, we can try to simplify this further to have delta y, which is equal to minus 2 sine. I want to split this. This is 2x divided by 2, which is x, plus this will remain delta x divided by 2. Then a sine of delta x divided by 2. I want us to have something here. If you get sine of a very small angle, if you are dealing with sine of a very small angle, you can try that one from your calculator, but make sure your calculator is in radians. If you are looking at sine of a very small angle, for example, 0.0009, if your calculator, make sure your calculator is in radians. If you have sine of a very small angle, someone who is having a calculator there can let us know what you are getting there. Sine of a very small angle, 0.009, when your calculator is in radians, what is this one equivalent to? If you have a calculator somewhere there, please try to put it. We want to make some small assumptions here. You get
8.9.
9
9. 9.
Again 9.
Yes. 87. 85.
Hey, is it 8.99 yes. Or 0.9 something?
It is 8.9.
Sure.
The exponent negative 4.
Okay. It is times 10 to the power negative 4. Okay. 4. Okay. Okay, I want you to get that one directly in the points. Put it in the up to around 4. You fix your calculator to 4 places, such that I get it as 0.000. I hope it will be 0.000899999 like that. When you fix your calculator, will it give you something related to that? We are waiting for you. Still, it can be easily seen. We are having 8.999, then times 10 to the power negative 4. So it should be able to give us something which is related to 0.0008999 like that. So when you look at, yes.
It is 0.009.
0.009. 09.
Yes.
Okay. So it will be a 9. So when you look at this and what you are getting here, you realize they are approximately the same. So sine of a very small angle, which can be measured in radians, is approximately the same as that angle. In other words, when you are taking sine of a very small angle, because delta x is a small angle, then divided by 2, sine of such an angle is approximately equal to that same angle, delta x over 2. As you can see, sine of 0.0009, we have got it still as 0.0009. So sine of a very small angle is same as that angle. Is that one okay? And before we leave that, we can also try cos. Please try for us cos. Try for us cos of 0.0009, and we see what it will give us. We are looking at cos. Get for us cos of 0.0009. Maintain your calculator in radians. We want to see what it will give at us.
Zero.
Yes, you get 0.999,
999.
like that.
Yes.
So this,
9.
yes.
Another 9.
Another 9.
5. 5. 9.
5, 9. So when you look at
5.
this value, you realize it is giving us 0.9999, something like that. Okay, thank you so much. So from these two expressions, sine of 0.009, cos of 0.0009, we shall get our assumptions that we shall be using. So we shall be using the two assumptions that cos of a very small angle is approximately equal to 1. Because when you look at this, cos of this angle, which is small, which can be measured in radians, is approximately equal to 1. And sine of a very small angle is same as that same angle. So this is the assumption that we shall take here. That since delta x is a very small angle in radians, since delta x is a small angle that can be measured in radians, then we shall be saying that when you take sine of delta x divided by 2, sine of delta x divided by 2, this is approximately equal to delta x divided by 2. As we have seen here, sine of a very small angle is approximately equal to that same angle. Cos of a small angle is approximately equal to 1. So whenever we have sine of a small angle, we shall be replacing it with that same angle. So from this given step here, we shall now have this step that says delta y is equal to negative 2 sine of x plus delta x divided by 2, then times delta x divided by 2. So from here, we are substituting this with delta x divided by 2. I hope that one is very okay. So that is minus 2 sine of that. So from this given point, our interest is to get dy dx. We are interested in differentiating cos of x. So we need to get the derivative of cos of x. So what we shall do here is, from this given step, we shall have this as, let us introduce in delta x. We want to divide through. So the next step is to divide through, dividing through by delta x, because I need to create dy dx. So divide through by delta x. And when you divide through by delta x, this expression here, divide on both sides by delta x. So this will be delta y divided by delta x, which is equal to minus 2 sine of x plus delta x divided by 2 times delta x divided by 2. But we are dividing this side also by delta x. What you do this side, do it the same on the other side. So from here, you realize that you can easily see that this delta x and this one will cancel out. So we shall remain with delta y over delta x, which is equal to minus 2 sine of x plus delta x divided by 2. I can as well cancel this one out. So this one will be out, such that we remain with only minus of that. So these two will cancel with this, delta x will cancel with that. So from this given step here, we are having delta y over delta x, which is equal to that. So what we shall do is, we shall now look at when delta x is becoming small. That is, as delta x is becoming smaller, is tending to 0. So from there, we shall have the limit. So we shall take the limit as delta x is tending to 0 of delta y, delta x. And this, when you take the limit to this side, do the same the other side. That is, limit delta x tending to 0 of negative sine of x plus delta x divided by 2. So take the limit on both sides. So when you do that, when you take the limit delta x tending to 0 of delta y delta x, this becomes dy dx. This becomes dy dx. You should be able to recall that from differentiation 1. So this will be equal to, now delta x is becoming smaller, is tending to 0. So wherever we have delta x on this side, put there 0. So it means when this one becomes 0, 0 divided by 2 is 0, so you remain with negative of sine of x. So what does this one imply? This implies that when you differentiate y, our y, remember, was cos of x. When you differentiate cos of x, you get negative sine of x. So that is how we differentiate a cos of x from first principles. Can I hope that the procedures are very okay for everyone? This is where we started from. And from this given point, please always recall some of these assumptions. When you take sine of a small angle, it is same as that angle. Cos of a small angle is same as 1. Those are some of the assumptions which will help you when you are trying to differentiate from first principles, especially for trig functions. So for that case, that is how we deal with a cos of x. So we can look at another. We look at how to differentiate sine of x from first principles. How to differentiate sine of x from first principles. So we shall follow the same procedures. So next we are looking at differentiation. We are basically interested in differentiating. We need to differentiate sine of x. So this is what we need. And we need to do this by differentiating this from our first principles. So let us now deal with that. So how do we deal with this? The procedures will remain the same. First, let your y to represent sine of x. If y is equal to sine of x, a small increment in x brings about an increment in y. So for that case, y plus delta y is same as a sine of x plus delta x. An increment in x brings about an increment in y. From here, you are interested in remaining with dy dx. So take this one the other side. Get delta y, which is equal to sine of x plus delta x. Then subtract y. Take y the other side. So y is sine of x. So I will have sine of x. So delta y will be same as. So if you have sine minus sine, can anyone remind us what this one becomes? For those who are following, what will this one be?
2 cos.
Yes, it will be 2
cos into bracket.
Yes, please.
X plus changing x.
X plus
small changing
x. Yes.
Plus x.
N plus x.
Then divide by 2.
Divided by 2.
Close bracket.
Yes, please.
Sine into bracket. X plus change in x, small change in x, minus x, divide by 2.
Divided by 2. Okay, thank you so much. I hope everyone is able to recall this from factor formula. If you have sine minus sine, it is cos that becomes big and sine becomes small. Okay, so from here, the next step is to try to simplify this. So this is 2 cos. This is x plus x. I want to do it at once. X plus x divided by 2 will give us x, then plus delta x divided by 2. Some of the steps should be now easier for us. Then this one here is the sine x and x will cancel, still will remain with delta x divided by 2. So from this given point, I should be able to write delta y, which is equal to 2 cos of x plus delta x divided by 2, then times. I hope it is very okay for everyone. Where there is sign of delta x divided by 2, we shall put there. What shall we put there? For delta x is a small angle that can be measured in radians.
We shall put the x over 2. We shall put that abnormal x over 2.
Okay, so we shall put that. Okay, that is very okay. So from this given point, we shall now try to introduce in delta x. And we shall introduce delta x by dividing through by delta x. So the next step is dividing through by delta x through by changing x. We shall be able to get. So this will be delta y upon delta x, which is same as 2 cos of x plus delta x divided by 2, and then times delta x divided by 2. At this given point, we are dividing by delta x on both sides. So from this, we should be able now to have a delta y over delta x, as 2 will cancel, delta x will cancel, we remain with cos of x plus delta x divided by 2. So from here, we shall take the limit as the next step. Take the limit on both sides. Limit delta x tending to 0 on both sides. So we have delta y, delta x. Do the same the other side. Limit delta x tending to 0 of what we have here, cos of x plus delta x divided by 2. So when we do that, when we take limit of delta x tending to 0 of delta y, delta x, this should be able to give us dy dx. Where there is delta x on this side, place there 0 because delta x is becoming smaller. So this will remain as cos of x. So this implies that when you differentiate sine of x, with respect to x, you will get cos of x. So you need to be knowing some of these because you will not always be proving from first principles. So you need to be knowing when I differentiate sine of x, what do I get? When I differentiate cos of x, what do I get? So when you differentiate cos of x, you get negative sine of x. And next we have seen when you differentiate sine of x, you get cos of x. So you must master some of these differentiation of trig functions. Okay, so I hope the procedures are still very okay for us. So that is basically about sine of x, and the next we need to talk about tan of x. So what do you get when you differentiate tan of x? Okay, so let us look at the differentiation of tan of x from first principles. Differentiation of tan of x. So we need to differentiate tan of x. So in other words, we need d dx of tan of x. So what do you get when you differentiate tan of x with respect to x? That is our major interest. Okay, so to look at this, we shall follow the similar procedures. One, we shall let y to be equaling to tan of x. If y is equal to tan of x, an increment in x brings about an increment in y. Y plus delta y is equal to tan of x plus delta x. Okay, so from this given point here, I want us to have this as delta y, which is equal to tan of x plus delta x minus y, and y is tan of x. So we are having tan of this minus tan of that. I want us to express this in terms of sine and cos. How do we express tan in terms of sine and cos? Anyone to remind us what is tan of
We
x?
say tan x is equal to sine x over cos of x.
Sine of x over cos of x. Thank you. So basically, we want to introduce all of these in terms of sine and cos. As she has said, we shall have delta y equaling to sine of x plus delta x divided by cos of x plus delta x. But we are subtracting sine of x over cos of x. Okay, from here we are having delta y, which is equal to, I want us to get the LCM from this given step. So can we have this as cos of x plus delta x times cos of x as our LCM? And when we get this LCM, we divide it by this, we shall get cos of x. We multiply it here. This will be sine of x plus delta x times cos of x minus, when you get this same LCM, you divide it by this, you will get that. So let me have this as sine of x. Then when I get this divided by this, I get this, so it will multiply here. So this is cos of x plus delta x. When we are beginning, we talked about the sum of the expansions for sine and cos. Okay, is there anyone who can easily tell us what this one that is in the numerator represents? We have sine of x plus delta x times cos of x minus sine of x, cos of x plus delta x. So when you look at what you have in the numerator, what do you think about?
I think of sine into bracket.
You think of
Sine
you think of sine
into bracket.
into
Bracket x plus
x plus
small change in x
small change in x
minus minus
minus
x.
minus x.
Yes.
Okay, thank you. Let us look at that. When you take this one to be like your a, this is x plus delta x. X to be your b. This is, again, when you look at this, this is your b, and this is your a. If you recall very well, when you have a sine of a minus b, sine of a minus b is same as sine of a cos of b minus sine of b cos of a. And as she has said, when you look at this one here, this is an expansion of sine of a minus b. So in other words, this is your a, this is your b. So this one here, what is in the numerator can be simplified, or can the equivalent form is sine of x plus delta x minus x, which is of this format. I hope everyone should be able to notice that. So we are dividing this by cos of x plus delta x, again cos of x. So this is our delta y. Okay, so from this given point, we can try to simplify this further. If you look at this, what you have here can be simplified to be sine, this is x plus delta x minus x, so x can cancel out, you remain with delta x, then divided by cos of x plus delta x, then times cos of x. So I hope we are still together up to that given point. From this point here, from this given point, if you recall very well, we said if delta x is a very small angle, this is a very small angle which can be measured in radians. So if it is a small angle that can be measured in radians, then this sine of delta x will be approximately equal to delta x. So that is the assumption that we shall take after this given step. So let us take that. Since delta x is a small angle, I hope we can write that. Since delta x is a small angle that can be measured in radians, so it implies that sine of a small angle delta x is approximately equal to delta x. And for that case, our expression that we had here, this will now become a delta y, which is equal to delta x divided by cos of x plus delta x, then times a cos of x, where there is a sine of delta x. Where there is sign of delta x, we are putting delta x. Sine of a small angle is approximately equal to that same angle. Okay, so from here, the next step will be to divide through. So let us divide through. So dividing through by delta x. Dividing through by delta x, we shall have delta y over delta x, which is equal to delta x over cos of x plus delta x times cos of x. But we are dividing through by delta x. So if that is the case, this delta x and this will cancel out. We shall remain with delta y over delta x, which is equal to 1 upon cos of x plus delta x, and then times cos of x. So from this given point, we shall take the limit. Don't forget to take the limit, because you can't get dy dx unless you have taken the limit here. So from this given point, we shall take the limit on both sides. So bring the limit on both sides. So limit as delta x is tending to 0. This side we have delta y upon delta x. So this is same as take the limit again on the other side. This side here we are having 1 divided by cos of x plus delta x, then times cos of x. So from here, when you take the limit, when delta x is tending to 0, delta y delta x will become dy dx. Then take the limit, delta x tending to 0, where there is delta x, the remaining delta x, put there 0. So this will be 1 upon cos of x times cos of x. This is 1 upon cos squared of x. This is dy dx. If you recall very well from trigonometry, what do you get if you have 1 over cos of x? I should ask someone here.
You get
Yes.
sec² x.
1 upon cos, 1 upon cos. 1 upon cos, what do you get?
You get
You get
sec²
x,
x.
sec x.
1 upon cos, you get sec of x. Then it means if we have 1 upon cos squared, then it will give us sec² of x. So this will be equal to sec² of x. So this is our dy dx. So what does this imply? This implies that when you differentiate tan of x, you get sec² of x. So we have so far discussed about sine of x, what you get when you differentiate sine of x, what you get when you differentiate cos, and what you get when you differentiate tan. Okay, next I want to differentiate one more, and you will try for me one maybe after that. I want to differentiate sec of x, and you can, okay, let us differentiate cosec. Cosec of x, you will try for me sec of x. Okay. So we still have a sec of x, we still have cosec of x and cot of x. Okay, so I will try one more, that is cosec. I'll try one more, that is cosec of x. I hope you are noting some of these things here, because these are the ones that will help us, especially when you start looking at differentiating some of the expressions consisting of polynomials and trig functions. You will need this knowledge. You will need to know what you get when you differentiate, for example, tan of x, what you get when you differentiate cos of x. Okay, so for that case, we have talked about 3 trig identities. I want us to look at the next. Before that, I want you to try for me this. What do you get when you differentiate? What do you get when you differentiate this? Y equaling to 3x² plus cos of x. You know how to differentiate polynomials. You know how to differentiate that. Anyone who can give us a quick answer there? If you are differentiating that, not from first principles. Yes, anyone? What will be dy dx?
I think you get
Hmm.
6x plus sine x.
You
No,
get
plus minus sine x.
x minus sine
6x
of x.
minus sine x.
Okay. Any other person who has a different answer? So do we all agree that when you differentiate this, you get this? Okay, so if we all agree, then that one is very okay. When you are differentiating this, you differentiate on both sides. You differentiate y with respect to x, differentiate 3x squared, then also differentiate cos of x. So in other words, when you differentiate y with respect to x, you remain with dy dx. Then when you differentiate 3x squared, drop the power, reduce the power by 1. So this should be 6 because it will be 3 times 2, 6x plus differentiate cos of x. We said you get negative sign of x. So in other words, dy dx is 6x minus sign of x, as she has clearly put it. So that is what you get when you differentiate that. So you need to be knowing what do you get when you differentiate tan, what do you get when you differentiate cos, what do you get when you differentiate sine. Because some of the expressions can be like this. Differentiate y equaling to x cos of x. Can we talk about this before we look at the differentiation of another? Which rule do you use here? If you have y equaling to cos, then x times cos of x, which rule do you apply?
Product rule.
You apply?
The product rule.
We apply the product rule, isn't it? Okay. So you should be able to apply the product rule here. So anyone who remembers how the product rule states, if you have y equaling to uv, where u and v are functions of x? Anyone who recalls that?
U
Yes.
du dx.
You
V
get,
du dx.
okay, let me write it here. Dy dx is equal to
V du dx
v du dx
plus U
plus u
dv dx.
plus u dv dx. Okay. Is there anyone with a different answer there? I hope everyone is also getting that. Okay, so this is what we call the product rule. So can we now try to solve this to try to get dy dx when y is equal to this? So what we do here is we let u to be equal to x, then we let v to be equal to cos of x. Okay, so what do you get when you get du dx here?
1.
You get 1, that is okay.
1.
dv dx,
Negative sine x.
we get negative of sine of x. Okay, so for that case, you can now go on and get dy dx. Dy dx will be same as uv. Okay, u v, we said it will give us v du dx plus u dv dx. So for that case, our v is cos. So it means this will be cos of x times du dx. Du dx is 1. Then plus u is
X.
u is x. So you will have x times dv dx. dv dx is
Negative sine x.
negative sine of x. So if we try to simplify this, we should be able to get cos of x minus x sine
Minus
of
x
x.
sine of x.
Is that one okay? So this is dy dx. So when you know how to differentiate some of the trig functions should be able now to deal with a product rule where you have trig functions. You should be able to deal with maybe implicit functions as well. So we shall be looking at more of these. Okay, so can you try for me this one here? Y is equal to x to power, okay, square root of x times tan of x. Anyone who can take us through that? You just tell me the procedures. I will be writing.
Let u be
Okay, we let u to be
x power half
x to power half.
u dx
Okay, du dx will be
a half power
a
3
half,
over 2.
a half,
3x a half x
a half x
power 3 over 2.
3 over 2.
Eh?
Are you deceiving us?
Negative
Negative
half.
half.
Eh?
Negative half.
That is negative
Negative
half.
half.
Okay,
Yeah.
that should be negative half because we reduce 1 in the power. So this is to power negative half. Okay.
Let v
So we have v there
tan x.
to be tan of x.
Dv dx
So the v dx will be equal to,
sec
it will be sec
squared x.
squared x. So when you differentiate tan of x, we get sec squared of x. Okay, that is good.
And then we use the product rule.
Yes, yes.
dy dx
Okay, we shall say dy dx is equal to
tan x
that is tan of x
times
times
a half x power negative a half
okay times a half x to power negative a half. Good.
plus
Plus
x power half
x to power half
times
times
sec x squared.
sec sec squared x, not sec of x squared. Okay. Yes.
Okay, sir.
There is a difference between sec squared x and sec of x squared. Okay, these are different. Okay.
Okay.
Okay. So we can simplify this further, but basically the procedure is okay. So others, you should be able to now to simplify this. This can be easily simplified, especially by bringing this one in the denominator, or else you pull it out. That is also okay. Someone can have this as 1 upon 2 as x to power half times tan of x plus x to power half, then sec squared of x. When you put this one in the denominator, you should be able to recall some of the properties of indices. If you have x to power negative a half, this can be written as 1 upon x to power half. So you can write it like that. So from here, you can get the LCM such that you have 1 upon x to power half out. Okay, you can have it in the LCM to avoid the confusion. So you can create your LCM there. Actually, the LCM is 2x to power half. So when you have 2x to power half divided by this, you will simply remain with 2x to power half divided by this. You'll get 1. So you remain with tan of x. Then plus 2x to power half divided by 1. You get 2x to power half. You multiply it here. So x to power half times 2x to power half. What do you get?
2x.
You get 2x.
We get 2x.
You get 2x. Okay, thank you. So
Yeah.
this becomes 2x, then sec² of x. So basically that is what you have when you differentiate at the square root of x and of x. So that is basically the application, some of the application of what we have so far talked about. So we have seen the differentiation of tan, we have seen the differentiation of sine, we have seen the differentiation of cos. I want to look at one more, especially on the reciprocals. We haven't talked about the reciprocals. That is for sec, cosec, and cot. So we want to look at the reciprocals. So far we have seen that when you differentiate cos of x, when you differentiate cos of x, you get
Negative sine x.
you get negative sine of x. We have seen that when you differentiate sine of x, you get
Cos of x.
you get cos of x. When you differentiate tan of x, you get
You get sec
Sec x.
you get sec². Okay, so that is basically what we have seen, but we haven't looked at how to differentiate. What is the reciprocal of cos? I want to check someone here. The reciprocal of cos at Gonza. Who is at Gonza Cronvis? What is the reciprocal of cos? At Gonza, you are off. Okay, I want to check someone here. Geoffrey. We have Geoffrey there. What is the reciprocal of cos? In other words, what is 1 upon cos?
Cosec.
Sec.
It is sec. Okay.
Cosec.
You cosec, sec.
Okay.
Sec.
Okay.
Sec.
You get sec.
Yeah, sec.
All right. Okay. Go on. What is the reciprocal of sine? The reciprocal of
Cosec.
sine
Cosec.
is cosec. And lastly, we want to talk about the reciprocal of tan.
Good.
So these are some of the trig functions that we have not seen, but let us also talk about them. So let me begin with cosec. Let me begin with cosec. So I want us to look at how we differentiate cosec of x. In other words, what do we get when we differentiate cosec of x? Okay, so the procedures are not changing. We shall follow almost similar procedures. So let us start. What we shall do here is to let y represent our cosec of x. If y represents cosec of x, then what will be y plus delta y? An increment in x will bring about an increment in y, and for that case, we shall have cosec of x plus delta x. So from this given point, delta y will be same as a cosec of x plus delta x minus cosec of x. But we want to put these ones back in their original forms, that is in terms of sine and cos. So what we shall do here is to have this as 1 upon cosec. Cosec, we saw that when you are dealing with cosec of cosec is same as 1 upon sine. So this is same as 1 upon sine of x plus delta x. Then minus 1 upon a sine of x. This should be easier, especially for those that were there when we were dealing with the differentiation of tan. So the procedures are almost similar. So delta y is same as we shall get the LCM here, the LCM of sine of x plus delta x, then times sine of x. So from here, sine of this is our LCM divided by this, we shall get sine of x. So this is sine of x times 1, it remains sine of x. Then minus this one divided by sine of x, we shall get that sine of x plus delta x. So at this given point, we should be knowing what to do. So how do we deal with the numerator there? Someone can unmute and tell us when you're having sine of x and a sine of x plus delta x, what do you do? Okay, here this is sine followed by sine. You should be thinking about a factor formula. So can someone tell us factor formula here? Expression we shall use, sine of x minus sine of x plus delta x.
Sine of x minus sine minus sine of x plus dx plus delta x.
You are using the factor formula or you are expanding this? Because we have two ways how we can do that. Which one are you using there? So I want us to talk about using factor formula here. Sine of x minus sine of x plus delta x. What do you get?
Two cos.
You get 2 cos.
Cos. Into bracket.
Yes.
X.
X.
Plus.
Yes.
X plus delta x.
X plus delta x.
Divide by 2.
Divided by 2.
Sine.
Then times sine of
X minus.
x minus.
X plus delta x.
I do it like this.
Yes. Then divide by 2.
Divided by 2.
Yes, and divide by 2.
Okay. So the whole of this should be over the denominator. X plus delta x times sine of x. Is it all? Anyone else who can? Thank you so much. This is okay. I want someone else. I want us to just try to put something small here. Is something small that is still missing? Anyone who has seen that? Oh, it is very okay. So basically, what she missed was only here, this bracket here of x plus delta x, because what you would get here would be x minus x, and this delta x would not be affected by this minus. And that one becomes a serious mistake there. Is that one okay? So especially when you are subtracting, yes, and this is x plus delta x, it is important that you try to put this bracket. Otherwise, this minus will only affect x. This minus would only affect x, and yet is supposed to be affecting all. So that is what was only missing. But otherwise, this is very okay. That is one way, but someone can first also expand this. But when you are expanding this, still make sure you maintain the minus there. Make sure you maintain the minus, put the expansion of sine of x plus delta x plus delta x, put the expansion of this in the bracket. You will also get the same answer. That is another way of how someone can try to do that from this given step. So from that step, we shall have this as, let us try to simplify this. This is 2 cos of, this is x plus x divided by 2. That will be 2x divided by 2, which is x. Then plus delta x over 2. Then this x and this x will cancel out. But we shall remain with minus of delta x. Is that one okay? Let me get it on a very good page. So this will give us 2 cos of x plus delta x divided by 2. Then here, this one here, this is sine. Let me put it here. This is sine of x minus x plus delta x. But the whole of this is divided by 2. So from this is same as having sine of this x will remove that, and we remain with negative of delta x divided by 2. That is what we shall remain with. So from that given point, it means here we shall have sine of negative delta x divided by 2. But we are dividing the whole of this. We are dividing the whole of this by sine of x plus delta x times sine of x. So this is sine of x plus delta x times sine of x. So this is our delta y. I want to ask someone there, what is sine of negative 60 degrees? Sine of negative 60 degrees, can we say sine of negative 60 degrees is same as negative sine of 60 degrees? Is this true? Or can you say sine of negative 60 degrees is same as sine of 60 degrees? Which one is right? If you take sine of negative 60 degrees, can we say it is same as negative sine of 60 degrees? Or this one here? So we have A and B. So what do you say? A or B? Can someone
B.
tell us? Is B? So someone is
Yes.
suggesting B. Any other person?
Clear.
Someone is suggesting A. So that is a draw, 1-1. So who is separating with the sides? You can try to put it in the chat box in case you are unable to speak. It is A. Someone else is suggesting A. Any other person? Oh, we are not sure.
A
So
and B.
A and B. Okay, so members, let us look at that. We can prove that. In case you have a calculator, you can try to put it. Sine of negative 60 degrees. What do you get? Then what is negative of sine 60 degrees? These are some of the things that you must be knowing. Sine of negative 60 degrees. Anyone who is near a calculator there? We want to prove that one. So we are having sine of negative 60 degrees. Make sure your calculator is in degrees. What are you getting there?
Negative root 3 divided by 2.
Root 3 divided by 2. Okay, what is sine of 60 degrees?
Root 3 over 2.
Over 2. So it means negative
Yes.
sine of 60 degrees is same as negative root 3 over 2. Is it true?
Yes.
That is true. So can we say that this one and this one are the same? So in other words, when you have sine of a negative angle, it is same as having negative of sine of that angle. And similarly, if you have cos of a negative angle, it is same as cos of that angle. Cos of a negative is same as cos of a positive. You can prove that. Sine of negative angle is same as negative sine of that angle. It's same as putting the negative outside. But cos of a negative angle is same as cos of a positive angle. All of them will give you the same answer. Okay. I hope that one is okay so far. And if that is okay, I want us now to come to this. I want us to come to this. You are having two cos of that. We were talking about delta x being a small angle that can be measured in radians. So what should sine of negative delta x over 2 be approximately equal to? Because we are saying delta x is a small angle that can be measured in radians. So if it is a small angle that can be measured in radians, what is sine of negative delta x divided by 2 equaling to? This is approximately equal to, for those that have been with us from the start, you should be able to give us the answer there.
dx, negative dx over 2.
So this should be equal
Negative
to
delta x
negative
over 2.
delta x over 2. Okay, thank you. So this implies that when you have delta y, this is equal to 2 cos of x plus delta x divided by 2. And then this one here will be replaced by negative delta x divided by 2. But we are dividing the whole of this by sine of x plus delta x times sine of x. Okay, so from this given point, I want us to divide through by delta x. So dividing through by delta x, dividing through by delta x, we shall have delta y upon delta x, which is equal to, this is 2 cos of x plus delta x divided by 2 times negative delta x over 2. We are having sine of x plus delta x times sine of x. But remember, we are dividing both sides by delta x. So delta x this side and also the other side. So when we do that, this delta x and this will cancel. These two and this will cancel. We shall remain with delta y upon delta x, which is equal to negative cos of x plus delta x over 2 divided by sine of x plus delta x times sine of x. This will be equal to, okay, from this given point, I want us now to take the limit on both sides. So when you take the limit on both sides, it will give us limit delta x tending to 0 of delta y upon delta x. So this will be, when you take the limit, ensure that you take the limit on both sides, delta x tending to 0. So here we shall have the limit of, you are just taking the limit within this, on this side and on that side. So that is negative of cos x plus delta x divided by 2 over sine of x plus delta x, then times sine of x. Yes, someone who has a hand here, sways by yet, something like that. Yes, the hand is up. Anyone who is lost? Okay, so in case all is well, when you take the limit as delta x is tending to 0, delta y delta x, you will get dy dx. Now, your delta x is tending to 0, which means that where you have delta x, where delta x is remaining now, you must now take it to 0. So this should now be 0. Where there is delta x, put there 0. So this will be negative cos of x over sine of x times sine of x. Okay, so I want to have this as negative 1 upon a sine of x. I want to split this in this form, cos of x upon sine of x. I want to simplify this further up to the point where it cannot be simplified anymore. So I'm simplifying this. I'm having 1 over sine of x, since this is sine x. Then I'm putting cos over sine. Okay, if you recall very well, 1 over sine will give us cosec. So this is
Cosec.
negative cosec of x. What about cos divided by sine?
Good.
So in other words, the y dx will give us negative cosec of x cot of x. So what does that one imply? This implies that when you differentiate cosec,
Buddy,
of x, you get negative cosec of x cot.
so
So I hope the procedures are very okay. And at the moment, we have here negative cosec of x cot of x. So whenever you differentiate cosec of x, you get negative cosec of x cot of x. So I want you to try for me sec of x and see if you use this similar procedures, whether you would be able to get this as sec of x tan of x. I hope you will be able to try that. And also, when you differentiate cot of x, you should be able to move up to a point where you will have this as negative cosec squared of x. So are you able to try any of these remaining two? This one here and this one here. Please, you follow the similar procedures. You follow similar procedures as we have done. So for example, how to deal with cosec, the same way we have dealt with how to deal with sec, the same way we have dealt with cosec. So this will be y, you let your y to be sec of x, then bring in a small change in x, it will bring about a small change in that. Then you will have cos of x here, then here you will have cos of x plus delta x. So you must know how to use factor formula here, or else, as I said, you must know how to expand this. You can first of all expand sine of x plus delta x using the knowledge of compound angles. Then don't forget this minus here, very important. It will affect whatever you will have as the expansion here. So the sec, you can follow similar procedures. And then to deal with cot, you will follow the same procedures as we have done for tan. It uses similar procedures as we have done for tan. So where there is tan instead, now it will be cot. So cot of x plus delta x, now put them back in their original form. Then an expression like that will appear. You should be able to know where this one comes from. So you should be able to try these two. Should be able to try these two. So try to test whether you are able to try out these remaining two. So from these two expressions, from these few expressions that we have seen, we can now come up with the general. We can come up with a general conclusion. If you look at differentiating cos of x, we got negative sign. When you look at this one here, when you look at cos, you are getting negative sign. When you look at differentiating cosec, you are getting negative cosec cot. When you look at differentiating cot, you look at negative cosec squared. So you realize that the trig functions which start with c, when you are differentiating them, you get a what? You get a minus. All trig functions which start with c, when differentiated, gives you what we call a negative in the answer. So whenever you are differentiating and you are dealing with cosec, you are dealing with cos, you are dealing with cot, don't forget that negative there. Very important. So that is how we differentiate trig functions, and especially we have seen this is for the case when you are having only a single angle. When you are having only a single angle, this is cos of x. But the angle can change. You might have, for example, y equaling to cos 2x. You must know how to differentiate this. So how do you deal with what we call the multiple angles? So I want us to look at how to differentiate multiple angles, and that it will help us now to know how to deal with all the differentiation of trig functions. So I will try maybe round 2, especially for half angles and any other angle which might be here. Then you should be able to begin from there. So can we try something to do with a differentiation of multiple angles? I want us to try one. Then you should be able, I will give you the general way of how we can differentiate. So long as you know what you get when you differentiate sine, when you differentiate cos, when you differentiate tan, and the differentiation of, for example, y equaling to cos of 3x will be easy. So the differentiation of y equaling to tan of 5x will be easy. So you can easily differentiate
Niba
that.
sorwa edward basitadde
You can easily differentiate that.
ngamba nze tebawuya byenjogera. Wangi? Ate bawuye nze byenjogera.
Hey. Okay, so can we go on?
Yes, sir.
Okay, so I want us to look at how to differentiate a cos of a 3x, or when you have any other angle other than a single angle. And from there, we shall be able to generalize everything. So I want us to look at only one, and from there, we should be able to deal with others. So I want us to look at the differentiation maybe for cos of 2x or any other angle. So let us begin with how to differentiate cos of 2x. When the angle changes, if the angle changes, what will happen? The procedures will still remain the same. We shall relate. I will now be moving a bit faster because we have already seen that. So y is equal to that. Bring a change in x, which will bring a change in y. So cos of 2 x, a change is in x. So this is x plus delta x. So this will give us delta y, which will be same as cos of, I can open this bracket to be 2x plus 2 delta x. But I will subtract y, bring this one to the other side, and this one will be cos of 2x. So this is delta y, which is equal to, someone to remind us what is the factor formula when you are dealing with cos minus cos. This should be easier now.
-2
We get
sine
negative 2 sine
2x
of
plus
2x plus
plus x plus 2 delta x
yes,
plus 2x
then plus 2x.
over 2
Divide this by 2, then
in bracket
multiply by
sine
sine
2x plus
2x plus
2x plus
2 delta x
yes,
2 delta x
minus
yes,
minus
minus 2x
plus 2x. We divide this by,
divided by 2
divided by
okay.
by 2
All right, thank you. We shall have delta y, which is equal, let us simplify this now, minus 2 sine of, this is 2x plus 2x, which is 4x, divided by 2. That will give us 2x.
2x
Then this is 2 delta x
plus delta
divided by 2, which will be delta x. Then sine 2x will cancel 2 delta x divided by 2. We shall remain with delta x.
delta x.
Okay, so I hope that one is okay. So from this given point, we said sine delta x is approximately equal to delta x. Because delta x is a smaller angle. So where there is sine delta x, I will put delta x. Okay, so from there, we shall have delta y, which is equal to minus 2 sine of 2x plus delta x times delta x. So from here, divide through by delta x. So dividing through by delta x. Dividing through by delta x, we should be able to have delta y upon delta x, which is minus 2 sine of 2x plus delta x times delta x divided through by delta x. So we shall be able to have this as delta x will cancel out, and next we shall have a delta y upon delta x, which is equal to minus 2 sine of 2x plus delta x. That is what we shall have when delta x cancels out. So from here we shall take the limit. take the limit as delta x is tending to 0. So limit as delta x tends to 0 of delta y upon delta x. This will be same as take the limit also, delta x tending to 0 of -2 sine of 2x plus delta x. When we do that, delta x is tending to 0. So where there is delta x, put 0. This will be -2 sine of 2x. So this will be dy dx. So what do we notice here? It means when you differentiate cos of 2x, you will get -2 sine of 2x. Now, this is the trick. If you are differentiating cos 2x, for example, you don't want to go through all this process. What you do is differentiate this angle. What you get is 2. Put the 2 there. Then, what do you get when you differentiate cos? When you differentiate cos, you get minus sine. That is what we said. You get minus sine. But return the same angle, which is 2x. So in other words, you will have -2 sine of 2x. Now, I want us to differentiate something like this. If you are differentiating sine of 3x, how do you differentiate this? What you do is, when you differentiate at angle, this angle here, the angle is 3x. When you differentiate this angle, what do you get? With respect to x, you get 3. So put the 3 there. So in other words, the angle here, the derivative of the angle here is what you multiply into the derivative of sine. So what is the derivative of sine? The derivative of sine is someone to remind us the derivative of sine?
Is cos.
It's cos. So it is cos. Then return the same angle, which is 3x. So, can someone try for us ddx of tan of 5x? Tan of 5x. Can someone tell us the answer there?
It is 5
It is 5
sec² 5x.
sec² 5x. Thank you.
Yes.
So it is 5 sec² 5 of x. So that is how we do it. So if you have ddx, you are differentiating cos over half of x. Cos a half of x. Someone should tell us that. If you are differentiating that using the similar principle, what do you get?
You get
Yes, please.
negative a half
You get negative a half
cos.
cos,
No, sine.
Negative half
Negative
sine.
sine.
negative a half sine.
Negative
Half sine x.
a half x.
Of x. So basically, differentiate this angle. The angle you are having here, differentiate it, then multiply it out. Then when you differentiate cos, you get a negative sign. So in other words, you differentiate this angle, which is a half of x, with respect to x. When you do that, you should be able to get a half. Then multiply by the derivative of cos. Derivative of cos is a negative sign. Then return the same angle, a half of x. So you'll be able to get negative a half sine a half of x. So that is how we differentiate cos. So then if you differentiate sec of 10x, sec of 10x, what do you get? When you differentiate sec of 10x, what do you get there? Anyone who can try? Please try it somewhere, then you let me know. First of all, you must
I
recall.
think you get
Okay.
10,
Okay. Let me.
10 sec.
Okay. 10. You are saying 10 sec.
10 sec
Hmm.
into brackets 10x
10x.
into brackets 10x tan
10 tan
into brackets 10x
10x. Okay. So that is basically what we get. So when you
tan 10x.
yes, tan sec
Yeah.
x, sec 10x, tan of 10x. In other words, you must be knowing what do you get when you differentiate sec x alone. When you differentiate sec x alone, as we said, is sec of x tan of x. So if that is the case, then if it is a tan, if you are differentiating tan a sec of 10x, what you simply do is differentiate this angle here with respect to x. This is like using chain rule. This is like using chain rule. So if I have sec of x, for example, as sec of 10x, what I can do is I can let like u to be 10 of x. Then what I do here, it means y will become sec of 10. 10 is u. 10x is u. So you are having y as sec of u. So what will be the y du? The y du is same as differentiating sec of u. But as we have seen, sec of u when differentiated is sec u tan u. When you differentiate this with respect to x, you will get 10. So in other words, if you are interested in the y dx, you will simply get the y du times du dx. And what is the y du is sec of u tan of u. What is du dx is simply 10. So this is same as having 10 as sec u tan u. But what is sec u? What is u? U is same as 10x. So this gives you 10 sec 10x and then a tan of 10x. So the most important thing here is when you are dealing with differentiation of trig functions, simply know these expressions here. What do you get when you differentiate? What do you get when you differentiate? When you differentiate sine, when you differentiate cos, cot, cosec, and sec. From there, you can manipulate any other thing from here. So you need to make sure that you master these because you will not be proving them all the time unless it is required. Okay? So is that one very okay? So before we come to the conclusion, one more thing I want us to talk about is higher powers. How do you differentiate higher powers? If you have, for example, if you have your y, if you have your y equaling to sine to power 3 of x, how do you differentiate that? So we can differentiate this just at a go, just looking at this, you can easily differentiate this. If you recall very well, I want us to look at this. If you have y equaling to 1 plus x squared, again squared. If you have this, can someone tell us how we can easily differentiate this? If you have y equaling to 1 plus x squared, again squared, how do we differentiate that? Anyone who remembers that? Without expanding this, you can easily use chain rule, but I don't want you to use that. I want you to give me the answer just at a go, at once, because there is an easier way of how we can easily differentiate this. Anyone who recalls how we can easily do that? You looked at differentiation of polynomial functions, so that should be easy. Did you look at doing like this, drop the power? reduce the power by 1, then multiply by the derivative. What is the derivative of the bracket? Derivative of the bracket. What do you get when you differentiate 1 plus x squared?
You get 2x.
You get 2x.
Yeah.
Are you still observing? Someone is saying is not saying what I'm writing. I don't know if it is a general problem. Is it a general problem, or you are able to see my board here? Members, are you able to see my board? Is it okay now? Okay. All right. So we were looking at, before that, let me first remove this. I wanted just to look at y equaling to sine to power 3 of x. So if I want to differentiate this, I started by asking if anyone can differentiate for me 1 plus x squared to the power of maybe 3. Let me increase the power now. How do you differentiate this? And what is the answer there? What is dy dx here?
The answer is
Yes.
3
3
into brackets
into
1 plus x squared
yes.
power
Yes. To power
power mm,
Power 2.
power 2
this is power 2.
Almost 2x.
into brackets
Yes.
2x.
2x.
Yeah.
Okay, so this is how
According to
we
what
do it. Yes, this is how we do it. 1, when you have the power, what you do, simply reduce, drop the power, differentiate normal. So drop the power, that is 3, reduce the power by 1, becomes 2, multiply by the derivative of the bracket, which is 2x. So in other words, you will get 6x into 1 plus x squared to the power of 2. Is that one okay? Okay. So I want us to use the same technique here. I want us to use the same technique here. If you have y equaling to sine to power 3x, what will be dy dx? What will be dy dx? I want us to use the same technique. Dy dx will be equal to, we drop the power, okay? Reduce the power by
Yes.
1, but multiply by the derivative of this function, because this can be written as sine of x to the power of 3. Now, what is the derivative of sine?
Cos.
Cos. So in other words, sine to power 3 of x is same as 3 sine to power 2 of x times cos of x. Is that one clear? Can someone now try for me this? Y is equal to a sine. Okay, we are done with sine. Let us try a cos to power 2 of x. Can someone get for us dy dx?
It is
Mm-hmm.
2
Is 2
cos
cos
cos x
of x.
cos x
Negative sign
is
times
negative sin x.
Negative sine of x.
Yeah.
Okay. But can this one be simplified further? We can simplify it again. So this is minus 2 cos x sin x. If we recall very well, what is this one equaling to? If you have negative 2 sine of x cos of x, what is it equal to? This one.
Negative 2 cos of x.
Okay. What is this expansion for? This expansion is for some known trig function. 2 sine of x cos of x. It comes from the expansion of what? This is the expansion of what?
Negative cos of 2x.
Negative cos of 2x. Sure. Sine x cos x. Anyone who recalls that?
Sine of 2a.
This is
Or
sine of
2x rather.
2x. This is
Yeah.
simply minus sine of 2x. So you should be able to recall sine 2x is same as 2 sine of x cos of x. Cos 2x is same as, anyone who recalls the two expressions that represent cos 2x?
Cos squared x
Cos squared
minus
x
sine squared x.
minus sine squared x. What else? It has
Yes.
got about three expressions. In terms of sine alone, what is it? In terms of sine alone? Do you still recall something like that?
1 minus sine squared x.
1 minus 2 sine squared of x. What about this? The one in terms of cos, you should be able to recall that. Okay. So basically, that is what we are having. So this is how we differentiate. If you are having cos squared of x, this is what we get. So we are almost coming to the conclusion. So at the moment, you should now be able to differentiate some of these expressions here. For example, if someone gives you to differentiate like y equaling to sine squared of 5x. Can we talk about this? Now here the power is a higher power. Again, the angle is also different. So what will be dy dx? You should be able to get these ones here very fast, because when you are looking at some of other functions, will be, for example, differentiating like x squared, sine squared of 5x. So you need to be knowing how to differentiate this one alone. Okay, so what will be dy dx? We shall do the same. Okay, drop the power. When you drop the power, it will be 2, reduce the power by 1, sine of 5x. But now, differentiate. Remember, this can be written as sine of 5x to the power of 2. So you are dropping the power, reduce the power by 1, you get this, but multiply by the derivative of sine of 5x. What is the derivative of sine 5x?
Fifth
A fifth?
cos of 5x.
1 over 5 cos of 5x?
Yeah.
Okay, thank you. Any other? What do you get when you differentiate sine 5x?
You get 2.
You get
2 sine 5. No?
Yes, yes. I'm waiting. What do you get when you differentiate sine of 5x?
Get
5.
5 cos 5x.
You get 5
5 cos 5x.
cos 5x.
Yes.
So can anyone Tell us which of these ones is now correct. We have this, we have this. Which one should we go with? So from what we said, when you are differentiating sine of 5x, what you do, you differentiate this angle, so you get 5. So differentiate 5x with respect to x, then multiply by the derivative of sine. Derivative of sine is cos. So you have cos, then the angle is 5. Return it back. So it becomes 5 cos of 5x. So in other words, here we shall multiply by 5 cos of 5x. And this will give us 2 times 5 is 10 sine of 5x cos of 5x. Still, if you look at this, someone should be able to tell us what is the expression that we can substitute with if we have sine of 5x cos of 5x.